Hello and welcome back. We're in our third lesson in our unit on circles, and today we're talking about arcs and chords. We talked a little bit about arcs last time, and we've talked a little bit about chords. Now we're putting them together, and we get to do a bit of algebra in this lesson too. So here we go. Points on a circle determine both chords and arcs. So in this particular circle, this here, well, that's chord AB. And this here, that's arc AB. In a circle, or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if you see here, it's saying that CD is congruent to AB. Those two arcs are congruent, which means the chords AB and CD are also congruent. So we can use that information to solve for x. 8x equals 2x plus 3, 6x equals 3, and x equals 1/2. In this example, they give you the measurement of the two arcs, and they're both 190 degrees, which means, again, the chords AB and BC, well, those are congruent. So we can set their measurements equal to each other. 3x plus 2 equals 5x minus 7, and solve for x. X equals 4.5. Now let's look at this one. It says in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So we have that circle R is congruent to circle S, which means that if these two chords are congruent, then so are the arcs. So 4x plus 7 equals 5x minus 1, and solve for x. Now, in a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So the flip side of that is, in a circle, the perpendicular bisector of a chord is the diameter, or radius. So here in circle Y, we know that the radius is 34, and we know that AB, the chord, is 60. They're telling us that the radius is perpendicular to the chord, which means it bisects the chord, which means AD is 30. The information also tells us the measure of arc AC is 71. So with this in mind, let's find a few other measurements. If the measure of arc AC is 71, then the measure of arc BC is also 71. And AD, well, we've already found that to be 30. What about YD and DC? Well, to find YD, let's move this radius over here. And you see I've created a right triangle where YD is the short side of the right triangle and 34, the radius, is the hypotenuse. So I can use the Pythagorean theorem to solve for that short side, and x equals 16. And then DC, the rest of the radius, is 34 minus 16, which is 18. In a circle, or in congruent circles, two chords are congruent if and only if they are equidistant from each other. So in this circle here, do you see how they're both 9 from the center? Each chord is 9 from the center, which means that those chords are congruent. So 7x minus 20 equals 3x, 4x equals 20, and we find that x equals 5. There's a lot more going on in circles than I had ever anticipated before. I hope you're enjoying learning a little bit. I'll see you next video.